Hi, this is the thin film measurement setup we've been working on this summer. The goal is to measure the thickness of a thin film deposited on a substrate. Such a measurement is possible because different wavelengths are reflected more or less than others. Measuring this change in the light spectrum allows for thickness to be calculated. The calculation relies on knowing the angle of the incident light, the polarization of the incident light, and the index of refraction and extinction coefficient for the film and substrate, both of which are functions of wavelength. The computer makes a guess for thickness and calculates the corresponding spectrum. It compares that to the measured spectrum and iteratively improves its guess for thickness. So here's the hardware that makes that measurement possible. The first thing is this optical fiber, which is our light source. Next is a polarizing film. This is necessary because it actually doesn't matter which polarization we use, we just have to know which one it is. After that is this collimator, which has the added benefit of attenuating the amount of light that hits the spectrometer. Turns out our source is too bright even on the lowest setting. Next, the light will hit the sample to be measured, or the reference sample as what's installed right now. And finally, that goes into this fiber optic cable, which goes to the spectrum analyzer, and well, that's all of the hardware. Next is the software and how to actually use this setup.
This is the VI that controls the motors and takes information from the spectrometer in our machine setup. The first thing you're going to need to do is make sure it's connected to the Arduino that controls the motors by changing the VISA resource. Ours is COM5. Depending on the computer and the connections, it might be different. So just change that if necessary. Now, once you start it, you're going to want to enable the motors and then home them in order to make sure you get the proper angles. If you don't home them, it's going to think it's at a different angle than it actually is. While it's homing, the light on the home button is going to be green. So wait for that to turn off and for there to be a completion message in the error output before you try and send it to an angle. Now you can send them to whatever angle you want. They're done with normalization to the incident light being 0 degrees. So you type in your angle and you hit OK, and it moves. And you can do the same thing for the other motor as well. Make sure that if you turn off the program, you re-enable and home them, because when you turn it off, it disables them and they move a little bit, so positions aren't guaranteed. The first measurement you're going to want to take involves just the substrate, not the thin film on the substrate. In this case, we're using chrome. So go ahead, put it in your slot, make sure your light is turned on, and then you're going to come over here and hit record. If you look at this intensity versus wavelength graph, you want to see a nice Gaussian shape that goes as far up as it can without clipping. Now it's probably going to clip around 16,000. So what you can do is adjust the integration time over here with the knob or with the arrows. So I'm just going to go ahead and click until I get a good Gaussian shape. See, if I go too much, it clips on the top. Just go down until you have a good Gaussian shape. Hit light reference in mode, and it should keep the measurement. Once you're satisfied with it, stop recording. Then you're going to want to change the modes to dark reference. Go over here, keep the substrate in still, just turn off the light. Now you're going to take your dark reference measurement. So hit record again. You're going to want to see a flat line at the bottom. Once you're satisfied with that, stop recording and change the mode. This time you're going to want to do the reflection mode. And over here, you're going to need to change out your slides for the one that has the thin film on the substrate. In this case, we have PMMA on the chrome. Put that in the slot, go over, and turn your light back on. And then go ahead and hit record again and take your reflection measurement. Now that you have all three of those measurement types that you're satisfied with, you're going to want to specify the refractive index of the thin film. If you don't do this and leave that blank, it's going to error. And then once you error this program, it abruptly stops communication with the spectrometer without closing it properly. So the next time you try and run the program, it won't be able to start communicating with the spectrometer, and then you're going to have to restart the whole computer. So make sure you fill in that box. Also make sure you fill in this box. This is a guess for the thickness. You can choose any reasonable guess and hit fit guess, and then afterwards you can change your guess, fit again until you see what you like. I'm going to try 200, then hit fit guess, and you'll see down here with this key, blue is the data for reflectance over this spectrum, and red is the fit. If you don't like the fit, you can decrease or increase until you see something better. The fitted thickness that is decided as the best fit in a range around the guess is displayed. Now, this fitting works in the nonlinear fit section of the VI, and it calls this other VI, which is a MATLAB script. Now, if you want to change the fitting function, you're going to have to change this MATLAB script. Right now it's hard-coded to only work for Chrome. You can see the sigma value is just for Chrome. If you're going to want to change it to another material, you're going to need to change this script in order to make it fit on the other VI. Okay, and once you've decided that you're done, you're going to need to stop both of these buttons here, because you can stop both the motors and the communication with the spectrometer separately. So stop both, and then you're done. Another feature of this that's not fully developed yet is the band gap feature. Now for this, if you want to run it, all you'll have to do is press this button to turn it on, and then select the N exponent, whether it's direct allowed, indirect allowed, etc. A graph will display on here, and then you can move these cursors around, and it will display the band gap here. Now the reason why this isn't functional yet is because we have not figured out how to take a transmission measurement, and this is reliant on transmission. But once that is recorded, this will be functional.